Hi everyone, this is Mr. Cervone. Welcome to my math channel. In today's lesson, we will be learning about rhombi. Let's get started with the following do now. In the figure shown, quadrilateral ABCD is a rhombus with perimeter 52 meters. The length of diagonal segment AC is 24 meters. What is the area in square meters of rhombus ABCD? So in order for us to solve this problem, there are a few properties that we need to know regarding rhombi. So it will be best to first introduce these properties and then go back to solve this do now problem. And it turns out that the properties of the rhombus are also related to its definition. So let's introduce the definition first. Okay, so here's the definition. And it also turns out that a rhombus can be defined in two different ways. The first way that it can be defined is in terms of a parallelogram. So a rhombus is a parallelogram in which two consecutive sides are congruent. Okay, so for example, if we have a parallelogram here, and let's say two of these consecutive sides are congruent, then this becomes a rhombus. Now, why do we need to state that only two consecutive sides are congruent? Well, because if we think about the properties of a parallelogram, we know that in a parallelogram, opposite sides are congruent. So in this case, let's label it first. So let's say this is A, B, C, and D. Then, for example, segment CD and AB are inherently already congruent because it's a parallelogram and opposite sides are congruent. And also segment AD and CD are congruent as well because, again, opposite sides of a parallelogram are congruent. However, if two consecutive sides are congruent, that means that all the sides are going to be congruent. And that's basically the definition, and that's how we can also visualize or understand what a rhombus is. It's basically a parallelogram in which all the sides are congruent, okay? Hence, we have a second definition, which states that a rhombus is a quadrilateral with all its sides congruent, as you can see here in the diagram. Now, why is it okay to say all the sides are congruent? Because it seems like that we get another shape here. It could be a square, correct? Well, if we end up with a square in which all the sides are congruent, well, in that case, it's also a rhombus. It turns out that every square is a rhombus, but not necessarily the other way around, okay? So that brings us now to the hierarchy of all the quadrilaterals that we have learned so far. Let's list them now. Okay, so first we learned about quadrilaterals. Now, within quadrilaterals, we have all these shapes that we have learned. So the next shape we learned was a parallelogram, and we know that is a quadrilateral. Then we learned about rectangles, which are defined as parallelograms. Then we learned about rhombi in today's lesson, which is also defined as a parallelogram. Now, it turns out that if you combine the rectangle and the rhombus, or basically if you share all the properties of a rectangle and rhombus, you end up with another shape here that is shown on the bottom. And that shape is a square, which we will investigate in our next coming lessons. Now, it turns out that there are other shapes in this quadrilateral hierarchy, so let me show them really quick as well. So we also have trapezoids that we will investigate in the next coming lessons. And it actually turns out that trapezoids are also connected to parallelograms. You can actually define every parallelogram also as a trapezoid. How? Well, stay tuned and I will show that in the next coming lessons. But anyways, here's the connection. Then we will be learning about isosceles trapezoid, which in reality are a subcategories of trapezoids, but also connected to rectangles. And again, I'm going to show you how in the next coming lessons. And again, in the previous lessons, we learned about quadrilaterals, we learned about parallelograms by defining it and showing all the properties as written here, and also we learned about rectangles in the previous lessons, which basically inherit all the properties of the parallelogram, plus we have that rectangles have a right angle and the diagonals of a rectangle are congruent. So in today's lesson, we want to learn about the rhombus. What are the properties of the rhombus now that we have defined it? Okay, so let's get to the properties. Obviously, the properties of the rhombus will entail all the properties of the parallelogram as well. So let's write that in here. Okay, so the first property of a rhombus is that it has all the properties of the parallelogram. Let's list them all. Okay, so these are all the properties of the parallelogram. But what we can do now is change the word parallelogram with the word rhombus. Okay, once we changed everything to rhombus, then it has all the properties of a parallelogram, namely, first, that the diagonal of a rhombus divides the rhombus into two congruent triangles. Secondly, consecutive angles of a rhombus are supplementary. Thirdly, opposite angles of a rhombus are congruent. Fourthly, that opposite sides of a rhombus are congruent. And last but not least, the diagonals of a rhombus bisect each other. Now, it has a few more properties in addition to the properties of the parallelogram. Which other properties could the rhombus have? Well, an additional property is that all sides of a rhombus are congruent. That's something that the parallelogram does not share, okay? Then the next property has to do with diagonals. Okay, so after drawing the diagonals, we can actually clearly see here, and it can be proven as well, that these angles here, the vertex angles, are going to be bisected here, okay? So let me draw them all in. Okay, so the diagonals of the rhombus bisect the vertex angles. And then there's one more thing that can be said about the diagonals, which can also be proven, is that the diagonals are indeed perpendicular to each other. Okay, so these are all the properties of the rhombus. Okay, so going back to our quadrilaterals hierarchy chart, we can clearly see how the properties are being inherited from the shape right before that. For example, in this case, we can see that the rectangle and rhombus both share all the properties of the parallelogram, but they each have their unique properties as well, okay? So if we look at the first two properties of the rhombus, those are really not worth proving because they really have to do with the definition itself of the rhombus, because we defined it as a parallelogram, hence we have the first property, and we also defined it as a quadrilateral with all its sides congruent, and that's why we have the second property. Now, the third and the fourth property is really something new. So why don't we go ahead and prove those properties for number 3 and 4, namely that the diagonals bisect the vertex angle and the diagonals of a rhombus are perpendicular. Okay, so let's say we're given a rhombus ABCD as shown in the figure. How do we prove that segment AC is perpendicular to segment BD? And also, how do we prove that those diagonals bisect those angles as shown? Again, let's get started with a statement reason table now. Okay, first, we are going to state that rhombus ABCD is given. And now we want to use the definition of the rhombus to somehow prove these triangles congruent. And that's really the key here. If we can prove the triangles congruent, then we can prove adjacent angles congruent as well. So let's do that. So first we can state that segment AC and BD bisect each other at E, because we know that the diagonals of a rhombus bisect each other. As a matter of fact, we were able to get this property from the fact that a rhombus is a parallelogram. So this is one of the properties that is inherited from the parallelogram itself. Next, we can say that point E is the midpoint of segment AC, which is the definition of a segment bisector, which then allows us to say that segment AE is congruent to segment EC. As a matter of fact, let me also mark that in the diagram. Okay, so we have these two segments that are congruent. So now we can repeat this and do the same thing for segment BD. So for step 5, we can say that E is the midpoint of segment BD. Again, that's the definition of a segment bisector. And therefore, these two segments here, BE and ED, must be congruent as well by the definition of a midpoint. Okay, so now we know something else, right? we know that by the definition of a rhombus that all sides must be congruent. So let's write that in as well. Okay, so here we have that segment AB, BC, CD, and AD are all congruent because that is the definition of a rhombus. As you remember, we defined the rhombus as a quadrilateral with all congruent sides, okay? Okay, so now which triangle can we prove congruent? It turns out that all these triangles are going to be congruent, okay? So we're going to pick pairs at a time. So let's say we're proving the following two triangles first. Okay, so here we can say that triangle ABE is congruent to triangle CBE because of the SSS postulate. And now we can show that by corresponding parts of congruent triangles, that angle AEB must be congruent to angle BEC. So if we look in the diagram, we can see that these two adjacent angles are congruent. And we know what happens when we have two lines intersecting, creating or forming congruent adjacent angles. Well, in that case, the lines must be perpendicular. Okay, so for step 10, we can finally say that segment AC must be perpendicular to segment BD, because if two lines intersect to form congruent adjacent angles, then the two lines are perpendicular. Okay, so we proved the first one. Similarly, now we can prove the other adjacent angles, basically angle 1 and 2 that are congruent, 3 and 4, 5 and 6, and 7 and 8, all those pairs. So the fact that we know that triangle ABE is congruent to triangle CBE, it must also be true that angles 1 and 2 are congruent. Well, and we know that's true because corresponding parts of congruent triangles are congruent. So all we need to do now is simply repeat the steps that we previously did. For example, we proved that triangle BCE is congruent to triangle DCE, SSS postulate, and as a result, angles 3 and 4 are congruent, again because corresponding parts of congruent triangles are congruent. Then we state that triangle ADE is congruent to triangle CDE, again SSS postulate, and as a result, angles 5 and 6 are congruent. And then finally, that triangle ABE is congruent to triangle ADE, because again the SSS postulate, and finally that 7 and 8, those angles must be congruent because again corresponding parts of congruent triangles are congruent. Okay, so we were able now to prove the other two properties here. And now we can all be convinced that these properties are always going to be true here. So again here in the figure, quadrilateral ABCD is a rhombus. We know the perimeter is 52 and the length of the diagonal AC is 24 meters. What is the area in square meters of rhombus ABCD? Okay, so here's the diagonal AC, which is 24 meters. And if we now draw the other diagonal in, we can see some sort of right triangles here, okay? Okay, as we can see, the diagonals are perpendicular. Actually, let's write that in first. So here we have the diagonals that are perpendicular, so we can now look at triangles, okay? There's something else that must be true about the diagonals. Well, we know that the diagonals bisect each other, and therefore each of these sides are 12, okay? So if we, for example, label this point, let's call it E, then we know that AE and EC will be equal to 12. Now, how can we use the perimeter now? It says the perimeter is 52 meters. So all the sides of a rhombus are congruent, which means that if we look at the perimeter of 52 meters, all we need to do is divide the perimeter by 4 because each side is congruent, and we obtain that each side must be 13 meters, okay? So now if we look at one of the triangles here, for example, if we look at triangle ABE, we know that the length of segment AB is 13, the length of segment AE is 12. So what's the length of segment BE? Well, if we apply either the Pythagorean theorem or we know about the Pythagorean triple, so here we obtain a value of 5 for the length of BE. So that allows us now to find the area of this specific rhombus, okay? For example, speaking of area of triangle ABE, we can find the area by simply multiplying 12 and 5, and then divided by 2. So the area of triangle ABE is simply 1/2 times 12 times 5, which is equal to 30. Now we know that all these triangles are congruent, and we were able to prove them previously in this lesson. So that means that we have 4 triangles and the total area must simply be multiplied by 4. So the area of rhombus ABCD is 120. Okay, so that's basically it for today's lesson. So here's a summary of today's lesson. Again, we learned about the definition of a rhombus, that it can be defined as a parallelogram or as a quadrilateral. And we learned about the properties of a rhombus, which inherits all the properties of a parallelogram, which can be defined in terms of its definition. And we also proved the additional properties for number 3 and 4 here. Okay, so that's basically it for today's lesson. Again, thank you for watching and have a wonderful day.